Continuing on energy change. In this question here, steam is passed through excess hot coke and the reaction occurs and the coke cool. Now with the usage of the word steam, it would have suggested to us that it is actually water vapor at a temperature of at least 100 degrees Celsius, if not more. And since a large amount of heat is required for the reaction to proceed, it would have suggested that this was an endothermic reaction because heat was actually taken in. Now, after acknowledging this, we are then tasked to find out what is the energy profile diagram for this reaction. A little bit of a run through back to classes itself. For any kind of reaction, we have A plus B, hypothetically represented as our reactant, which will always give a value of 100 kilojoules to produce C, the product of this reaction. Since this is an endothermic process, I'll put a heat in of 10 kilojoules. So if the value on the left, summing up, is 10 plus 100 to give us 110 kJ, has to be equal to the value that's on the right. This tells us that the product should have an energy of 110 kilojoules. Now comparing 100 to 110, we can then conclude that the energy of reactant is much lesser than the energy of product. In addition, when we are putting on the labels from reactant to the peak of the graph, this is represented as the activation energy of a reaction. And for this question here, they did mention that activation energy is given the value of X. We also have from reactant to product. This will be representative of enthalpy change, not that the question actually required. So to plot out the diagram here, I know that my energy of R should have been much lower than the energy of my product. Filling in the information from the question, my reactant would have been carbon solid plus H2O gas, and my product will actually be carbon monoxide gas plus hydrogen gas. Completing with the curves itself, at the peak of this would have been my activation energy from my R to my peak, which comes at a value of X. Now, not that the question did mention, but from reactant towards product, this should have been represented by my enthalpy change with a positive sign to show that this is endothermic. And with this, the correct answer will be C in the question here. Reactant, product, and peak of the graph. And you can see that going upwards, this is the activation energy represented by the value of X.